So till now we talked about CYK algorithm. In this video we'll talk about probabilistic CYK algorithm. So the difference between probabilistic CYK and normal CYK is CYK algorithm uses CFG and probabilistic CYK algorithm uses PCFG. So the rules are like it must be a CFG context free grammar, but there is some probability associated with each of the production rules. For instance, for start of the sentence providing NPVP, the probability is 0.8. NP gives det and probability is 0.3. So in PCFG there is also a probability that is provided to us in the corpus, or it is generated with the help of corpus provided to us. So this is the difference. And PCFG also must be in CNF form, Chomsky normal form, which we have discussed in the previous videos that we saw on CYK here. So for probabilistic CYK, what we need is PCFG. What is the use of probabilistic CYK? So CYK normal algorithm, it helps us to generate a parse tree, but in probabilistic CYK this also helps us to generate a tree for an input sentence. But if in case there are multiple parse trees that can be generated with the help of the grammar, we can choose a tree which is more suitable, and based on the probability, the one tree that has the higher probability is basically used or can be predicted as part of probabilistic CYK algorithm. So the first basic example we will see, and then we will see an example where we have two trees, and then we will calculate the probability of the two trees and see okay which is the better tree based for a sentence as per the given grammar. So assume we have been provided a sentence, the flight includes a meal, and the what we have to do is we have to use probabilistic CYK algorithm. Why? Because we have been provided PCFG, and which has some probability for each of the production rules. So the process remains the same. We just need to generate a matrix as we had done previously. So we just count the number of words that are present in the sentence. Name it like 0, 1, 2, 3 and 4. Okay, so we will just create a matrix. The flight includes a meal. Okay. Name it as like term it as 0, 1, 2, 3, 4. Similarly, we can also write 0, 1, 2, 3, 4. It is up to us if we want to write the same words here. So we just need to fill this matrix on the chart. Now here if we look at 0, 0, so the word is the, and it comes from, okay, so it comes from this rule, that gives the, so we will just say that here, and along with that we will also mention the probability. So the probability that we see is associated is 0.4. So that also we have to fill here. So the rules are same, we just need to fill the diagonal first and then the cells which are above the diagonal. So upper triangular matrix in total we have to fill. Now if we look at 1, 1, so the word is flight, it comes from n and the probability is 0.02. Okay. Next word includes at 2, 2, so includes, it's a verb, and the probability that we see is 0.05. Okay. Next word o, so it comes from this rule, so we'll just put that, and the probability is 0.04. Okay. Next meal, so meal comes from this rule and the probability is 0.01, and it comes from this. Now now we have filled the diagonal. So what we need to do next is we need to fill all the remaining cells. So here this has been filled. Now what we'll do, we'll fill this. So 0 and 1. So that means let's assume, let's call this matrix as T, and we will fill each of the cells now. So what we are filling is this one, 0 1. So T 0 1. So it can be written as T 0 0 T 1 1. Okay, so T 0 0 T 1 1. So T 0 0 is this word, and 1 1 is this flight. So here if you see T 0 0, it contains det, and 1 1 it contains noun. So what we are going to see is we will look for a rule which has det n. So the second rule, if we see, that has det n. So it comes from here, np. So this becomes np. Yeah, and the probability is 0.3. So we will write that 0.3. Okay. Now once this has been filled, we will look for the next. This one we have to fill. So that is 1 2. So T 1 2 we need to fill. So this becomes T 1 1 T 2 2. Okay. So T 1 1 we know it is N, and 2 2 is V. Okay. So now we need to look for any rules which have N and V. So there is no rule that produces NV, so we will just put phi or null or whatever you want to, so that becomes blank. Now we will move to this cell, so that is T02. So T02. Okay. Now here if you see T02, so that means we have 0 1 2. So that the flight includes. So it can be like the would be alone and flight and includes are together, or the flight are together and includes is alone. So we will break it like, let's suppose we have like 0 1 2. So 0 and 1 2 together, 0 1 and 2, 0 and 1 together, and 2 alone. So here if we look like, so it becomes T0 0 into T1 2. Okay. So here if we fill these values, so T0 0 is det, and T1 2 1 2 is again 5 or nothing. So this becomes 5. Okay. Similarly here 0 1. So T0 1 is NP, and 2, that is T2 2 NP into V. So NP into V, we do not have any such rule, so this also becomes 5. So we can just put a blank here as well. Blank or 5, anything means the same. Okay, so we move further. Now this is the cell we need to fill. So this is 2 3. So we need to calculate T2 3. Okay, so this is T2 2 T2 3 3. Okay, so we know the value of T2 2, which is V, and 3 3 is det. So we just look for the rules which have V and det. Okay, so there is no such rule that produces this. So the unit becomes 5 or null. We fill that value here. Okay, now we need to fill this. So 1 3. So T 1 3 we need to calculate. So that means we have indexes 1 2 and 3. 1 can be alone, 2 3 together, 1 2 together, and 3 alone. So this becomes T11 T23, and this one becomes T12 T33. Yeah. So here if we calculate this, okay, so T11 is N, 2 3 is again 5 or null, so this becomes 5. Okay, now here if you look 1 2, so 1 2, this is again 5, and 5 into another thing that would become basically 5 alone, so this is also done. Okay, now similarly we will calculate this. So 0 3, so T03 again by the same rules we can calculate T03. So we have indexes 0 1 2 3. Since on the right hand side of every production rule we can have only two non-terminals, so what we can maximum combine is like split it into is like two parts, so 0 and then 1 2 3 together. It could be 0 1 2 3 together, 0 1 2 and 3 alone. So these are the three parts. So here it will become T00 into T1 2 3. So here if you look at T00 is det and T13 1 3 is 5, so this becomes 5. Okay, now here if you look T01, now here if we look at T01, so what we get is NP into T23 2 3, NP into 5, that becomes 5 alone again. Now the last one is 0 1 2, so that is T0 to 2 into T33. So 0 2, that is 5 into 3 3 is a det, but 5 into det would become 5 alone, so this is also not available. So till this we have filled. So similarly we will keep on calculating. So I'll just like fill this one and rest can be calculated. Now if we look at T3 4, so for T3 4, if we look, it will become T33 T4 4, square brackets you can put. So 3 3 is det and 4 4 is n, det n. So det n is np, so we get to know that np. Okay, so np and the probability is 0.3, so that we will fill. Yeah. Okay. Similarly we move up the cell. For this one we will get vp and it would be 0.2. For the further cell we will not be able to fill this one. It would result into 5, and then we calculate finally T04. Okay, so for T04 we will split it into, it could be like T00 T124 or T01 T224, or it could be 202 T34, or it could be T03 T44. So these are the four possible combinations that we will calculate. T00 into T14, that is det into 145, so that becomes 5 or null. Okay, T01 into T24, 201 is NP and 24 VP, so that becomes NP VP. So that is start of the sentence. Okay, so we get S here. S gives NP VP. Again T02 0 2, that is 5 5 into something is 5 alone, so that's null. Now T03 03 is 5 5 into something is 5. Okay, so all we get is like 1, so this is S. So if we get S here, that means the sentence we were able to parse, it is syntactically correct as per the probabilistic CYK and the given PCFG. So at the end, if somebody asks like what is the total probability of the sentence, so how do we calculate this? all we need to do is, let's suppose this tree whatever we have generated is called as T1. So probability of T1 would be, so this has probability 0.8, so we write that 0.8. So what we will do, we will multiply all of these. So 0.8 into 0.3 into 0.4, the next row 0.02 into 0.2 into 0.05 into 0.3 into 0.4 into 0.01. So whatever you calculate, that becomes your total probability for the sentence, for this sentence using this PCFG. Yeah. So in the next example, we will look into two trees and then we will calculate which is a better tree based on some PCFG. Thank you.